And I'm back. And here we go. Function operations. All right. And let's see here now. Okay, so just 22 questions. Perform the indicated operation. So first, add the pair of functions together. And then substitute in 8 and see what you get. (64) times it by -2, you get -128. And add 24 to get a final answer of -104. Divide one function by another. Divide function h by function g. And substitute in -4 and see what you get. -4 cubed is -64 minus -64. That gives you +64. This turns into +8. This turns into +8. And we take off 1. And we get a final answer of 72/7. And we check these two. And they're correct. Okay. This is just function multiplication. So multiply one function by the other. Multiply function f by function g. So 2t take 3, multiply by t cubed plus t. You could multiply that out, but you'd have to substitute in 0 anyway, so you may as well just do it within these simpler pieces. So 2 times 0, take away 3 is -3, and 0 in that piece there will give you 0, and so the final answer is 0. This is function composition. Function f is fed into function g. So pick up the definition of f, which is n squared minus 1, and plug it in right there in function g. So minus sign, and then an open pair of brackets, and then +5, getting it all ready to pick up f and put it inside. Now put in n squared minus 1, and there you go. Now to plug in 6. When I plug in 6 there, I square it and get 36. Take off 1, I get 35. Make that negative, I get -35, and add 5, and I'll get 30. And we check. Oh no. Why is there a mistake? Oh, beg your pardon, no. I meant to say -30. Because I'm speaking aloud. Okay, here it's function multiplication again. So just getting in the habit of putting them right next to each other like that. And then I have to substitute in -4. So do I multiply it out? No, just plug it in the pieces. -4 plus 2 is -2. -4 cubed is -64. Negative 4 times negative 2 is 8. And negative 64 plus 8 is negative 56. To get a final answer of 112. Here, just add the functions together. So you get x squared at 3x, and then plug in negative 3, just like that, and you'll get 9, take away 9, which is 0. Function h divided by function g. And this time, they're not asking you to plug in a number, but instead just give me the definition of function h divided by function g. And there it is. That's the definition. Now they're asking you for function g minus function h. So just write out function g in brackets, and then a minus sign, and then function h in brackets. And perform the subtraction. You get minus x squared plus 9x minus 2. And we check, and that's all correct, and that's good. Adding the functions now, we get 4x plus 8. Timesing the functions now, 2t minus 2 by 4t plus 4. And we'll get 8t squared, and then 0, and then minus 8. Check, all correct. Divide g by t, so put this on top, rather divide g by f, so put this on top and this on the bottom, and when we factor it, we can't actually. That's actually as simple as it gets. Now do function h take away 5 lots of function g. Okay, so that'll be 2n add 1, and then take away 5 lots of n take 2. And when we do that, we get negative 3n. That's a plus 10, so plus 11. Just there, like that. And we check, and that's good. Now we have negative 4 lots of g. So I'll do that in my head. So that's that. Plus 5 lots of h. So that's 10n take 15. So first we just simplify that. And then we have to substitute in negative 2n. So that's going to be 4n, because I just plug it in there. Take away 19. And here it's h composed with g, so pick up g and stick it in h. That's the first move. And when we do that, we get 12n take 7. And now we have to put 4 plus n where n is there. So it becomes 12n plus 41. And we check, and that's good. Function g take away function f, well, that would be that one. And now we have to plug in t over 2. And when we do this, we get that. Now add the functions together. All right. And substitute in negative t. And that's your answer. Okay. Find f and g so that h of x is equal to f composed of g of x. Neither function may be the identity function. Because that makes it too easy. Okay, so make g of x x squared, and make f of x 5 over x plus 1. Make g of x square root of x, and make h of x x plus 1 all squared. Make g of x this nice linear function right here, and make h of x the square root of x all plus 1. Make g of x the square root of x plus 1, and make h of x 3 to the x. Make g of x square root of x plus 3, and make h of x x all squared. Make g of x x squared, and make h of x 4 over x and 2. And we check, and there are many possible answers, and on some we agree, and I think we actually agree on nearly all of them. Yep, we actually do. Okay, that's cool. Although there are alternatives. And now, inverses. We must state if the given functions are inverses, and there are 16 problems altogether. And here we go. No, they're not inverses. For example, if I feed 10 into G, I get negative 40, and if I feed it into F, and if I feed negative 40 into F, I get 239, which is not 10. Okay, so what I'm going to do is I'm just going to figure out or remind myself rather, of the like that. So in this particular case up here, we have 2/9 there, and it needs to be the reciprocal, and it is. And over here, we've got plus 10/9, and it needs to be the negative of 10/9 over 2/9. So 10/9 times 9/2, and that is indeed correct. So yes. And we check. Good. No, it should be the reciprocal. Good. X over A take B over A. X over A take B over A. X over A take B over A. Good. That's just 5, isn't it? So, yes, I believe that's that. Is that right? I don't think that's right. No, that's not right. Okay, y at 2. Y to 2. Oh, good. Okay, check. Oh, nice. Okay, that's good. Oh, very nice. Look at that. Find the inverse of each function, then graph the function and its inverse. Okay. So y take 2, all to the 5, take 1. I should kind of be able to do that now without the y. Just there like that. Now the function itself is x to the 5, and then it's translated to the right by 2 and down by 1. There's the inverse. You know what? Oh, that doesn't look right at all. So we fix things. Okay. Very important. Okay, it starts off low like that. There like that. And the inverse of it. Like, it's reflected across y equals x, right? But there has to be an efficient way to do this. For me to just think about this. And I think that is the most efficient way for me to think that whatever's going on here, but just like up there. Like there. Like that. Okay.
Post the box through a letterbox. What? You know the box? Yeah. You just post it through the letterbox. Yeah. Yeah.
like that-ish. And then like there's the inverse and the non-inverse. Is that right? That's interesting. That's interesting. No. Oh, darn it. Apparently I'm out of time. All right, so very quickly, a function that doesn't have an inverse. Well, I mean, x squared doesn't really have an inverse. Yeah, I mean, I don't know why I shouldn't go with that. And find the inverse of f of x equals that. Well, you would think it would be this. But for now, we've got to go. Be well.